Myself B. Chanakya, and I am from ECE3A, and today I am going to explain digital signal processing in communications. Digital signal processing is a study of a signal in a digital representation and the processing methods of these signals. DSP and analog signal processing are subfields of signal processing. DSP has at least three major subfields: audio signal processing, digital image processing, and speech processing. Since the goal of DSP is usually to measure or filter continuous real-world analog signals, the first step is usually to convert the signal from an analog to a digital form by using an analog to digital converter. Often, the required output signal is another analog output signal, which requires a digital to analog converter. The digital signal processing can involve linear or non-linear operations. Non-linear signal processing is closely related to non-linear systems identification and can be implemented in the time, frequency, and spatiotemporal domains. The application of a digital computation to signal processing allows for many advantages over analog processing in many applications, such as error detection and correction in transmission, as well as data comprehension and data compression. Digital signal processing is also fundamental to digital technology such as digital telecommunication and wireless communication. DSP is applicable to both streaming data and static stored data. And the block diagram of a digital hearing instrument. Now the microphone is connected to a preamplifier, and the preamplifier is connected to an analog to digital converter, and it is connected to a digital signal processor. The digital signal processor is connected to a digital to analog converter. The digital to analog converter is connected to the final amplifier. The final amplifier is connected to the receiver. And coming to digital modulation techniques, three most commonly used digital modulation schemes for transmitting digital data over bandpass channels are amplitude shift keying, phase shift keying, frequency shift keying. And coming to the amplitude shift keying is a form of amplitude modulation that represents digital data as variations in the amplitude of a carrier wave in an ASK system. The binary symbol 1 is represented by transmitting a fixed amplitude carrier wave and fixed frequency for a bit duration of t seconds. If the signal value is 1, then the carrier signal will be transmitted, otherwise a signal value of 0 will be transmitted. Any digital modulation schemes uses a finite number of distinct signals to represent digital data. ASK uses a finite number of amplitudes, each assigned a unique pattern of binary digits. Usually, each amplitude encodes an equal number of bits. Each pattern of bits forms the symbol that is represented by the particular amplitude. The demodulator, which is designed specifically for the symbol set used by modulator, determines the amplitude of the received signal and maps it back to the symbol it represents, thus recovering the original data. Frequency and phase of the carrier are kept constant. And coming to ASK modulator, ASK is a type of amplitude modulation which represents the binary data in the form of variations in the amplitude of a signal. Any modulated signal has a 5 frequency carrier. The binary signal when ASK modulator gives a 0 value for low input when it gives a carrier output for high input. The following inputs to find the process of obtaining the ASK modulated wave let us learn about the working of the ASK modulator. And coming to the ASK modulator, the ASK modulator block diagram comprises of the carrier signal generator, the binary sequence from the message signal, and the band limited filter. The carrier generator sends a continuous high frequency carrier. The binary sequence from the message signal makes a unipolar input to the either high or low. The high signal closes the switch, allowing a carrier wave. Hence, the output will be a carrier signal at high input. When there is a low input, the switch opens, allowing no voltage to appear. Hence, the output will be low. The band limiting filter shape the pulse depending upon the amplitude and phase characteristics of the band limiting filter or the pulse shaping filter. And coming to the ASK demodulator, there are two types of ASK demodulation techniques. There are asynchronous ASK demodulation or detention. Second one is synchronous ASK demodulation or detection. The clock frequency at the transmitter when matches with the clock frequency at the receiver, it is known as a synchronous receiver method. As the frequency gets synchronized, otherwise it is known as asynchronous. Asynchronous ASK demodulator. The asynchronous ASK detector consists of a half wave rectifier, a low pass filter, and a comparator. Following is the same. The modulated ASK signal is given to the half wave rectifier, which delivers a positive half output. The low pass filter suppresses the higher frequencies and gives an envelope detected output, from which the comparator delivers a digital output. And coming to synchronous ASK demodulator. Synchronous ASK detector consists of a wave square law detector, low pass filter, a comparator, and a voltage limiter. The ASK modulated input signal is given to the square law detector. A square law detector is one whose output voltage is proportional to the square of the amplitude modulated input voltage. The low pass filter minimizes the higher frequencies. The comparator and the voltage limiter help to get a clean digital output. And now coming to the phase shift keying. The phase shift keying is a digital modulation technique in which the phase of a carrier signal is changed by varying the sine and cosine inputs at a particular time. PSK technique is widely used for wireless LANs, biometric contact lens operations along with RFID and Bluetooth communications. PSK is of two types. Depending upon the phases, the signal gets shifted. They are binary phase shift keying, that is BPSK. This is also called as two-phase PSK or phase reversal keying. In this technique, the sine wave carrier takes two phase reversals such as 0 degrees and 180 degrees. BPSK is basically a double sideband suppressor carrier, that is DSBSC modulation scheme for message being the digital information. And another one is QPSK, that is quadrature phase shift keying. In this phase shift keying technique, in which the sine wave carrier takes four phases reversals such as 0 degrees, 90 degrees, 180 degrees and 270 degrees. If this kind of technique are further extended, PSK can be done by 8 or 16 values. Also, depending upon the requirement, the BPSK modulator. And now coming to the BPSK modulator, the binary phase shift keying consists of the balance modulator, which has the carrier sine wave as one input and the binary sequence as the other input. The modulation of BPSK is done using a balance modulator, which multiplies the two signals applied at the input. For a zero binary input, the phase will be 0 degrees, and for a high input, the phase reversal is of 180 degrees. The output sine wave of the modulator will be the direct input carrier or the inverted 180 degrees shifted input carrier, which is a function of the data signal. And now coming to the BPSK demodulator, the block diagram of BPSK demodulator consists of a mixer with a local oscillator circuit, a bandpass filter, a 2-input detector circuit. By recovering the band limited message signal with the help of the mixer circuit and the bandpass filter, the first stage of demodulation gets completed. The baseband signal, which is band limited, is obtained, and this signal is used to regenerate the binary message bit stream. In the next stage of demodulation, the bit clock rate is needed at the detector circuit to produce the original binary message signal. If the bit rate is a submultiple of the carrier frequency, then the bit clock regeneration is simplified. To make the circuit easily understandable, a decision making circuit may also be inserted at the second stage of detection. And now coming to the frequency shift keying. Frequency shift keying is also known as FSK. And the frequency shift keying is a frequency modulation scheme in which digital information is transmitted through discrete frequency changes of a carrier signal. The technology used for communication systems such as telemetry, weather balloon, radio sounds, caller ID, garage door openers, and low frequency radio transmission in the VLF and ELF bands. The simplest FSK is binary FSK, that is BFSK. The BFSK uses a pair of discrete frequency to transmit binary, that is zeros and ones information. With this scheme, the 1 is called the mark frequency and the 0 is called the phase frequency, that is phase frequency. And the FSK modulator, the two oscillators producing a higher and a lower frequency signals are connected to a switch along with the internal clock. To avoid the abrupt phase discontinuous of the output waveform during the transmission of the message, a clock is applied to both the oscillators internally. The binary input sequence is applied to the transmitters so as to choose the frequencies according to the binary input. And now coming to the FSK demodulator. There are different methods for demodulating a FSK wave. The main methods of the FSK detections are asynchronous detector and synchronous detector. The synchronous detector is a coherent one, while asynchronous detector is a non-coherent one. Asynchronous FSK detector. The asynchronous FSK detector consists of two bandpass filters, two envelope detectors, and a decision circuit. The FSK signal is passed through two bandpass filters, that is BPFs, tuned to space and mark frequencies. The output from these two BPFs look like ASK signal, which is given to the envelope detector. The signal in each envelope detector is modulated asynchronously. The decision circuit chooses which output is more likely and selects it from any one of the envelope detectors. It also reshapes the waveform to a rectangular one. And coming to the synchronous FSK detector. The block diagram of a synchronous FSK detector consists of two mixtures with local oscillators, circuits, two bandpass filters, and a decision circuit. When digital data is transmitted over an all digital network, a scheme known as pulse code modulation is used. And the applications of digital signal processing. Digital signal processing has different types of applications in diverse fields like digital filtering, spectral analysis, speech processing, image processing, radar processing, robot control, telecommunication, consumer electronics, biomedical engineering, military application. In graphic equalizer, sound as well as frequency levels can vary to produce special sound effects and compensate for the lower sensitivity of the ear. Enhancement of edges in images improve recognition of object by human or computer. Edge. A sharp transition in the image brightness, sharp transition in a signal from Fourier theory appears as high frequency components which can be applied or amplified. Thank you.